Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P24B8-1C, also referred to as P24B8, indicates an issue with the Evaporative Emission Leak Check Module, ELCM, pressure sensor in the Honda CR-V from the 2023 model year and onwards. When the output voltage of the ELCM pressure sensor exceeds or falls below the specified range, the Powertrain Control Module, PCM, determines there's an abnormal condition and subsequently stores this DTC. The ELCM and its associated sensor play a crucial role in measuring the pressure within the evaporative emission system, which is responsible for preventing fuel vapors from escaping into the atmosphere. These components are typically located near the fuel tank and are integrated with the vehicle's emissions control system. Understanding this DTC is essential for diagnosing potential faults in the vehicle's emission system, ensuring compliance with environmental standards and maintaining vehicle efficiency. The DTC P24B8-1C specifically relates to the Evaporative Emission Control Module's pressure sensor. This sensor measures the pressure changes within the fuel tank's vapor recovery system, ensuring that any evaporative emissions are effectively contained. Its primary role is to detect leaks that could allow fuel vapors to escape, helping to maintain the vehicle's emissions within regulatory limits. The ELCM pressure sensor is usually found integrated within or closely connected to the ELCM, which is located in proximity to the fuel tank. By monitoring pressure, the sensor provides critical feedback to the PCM, which manages the vehicle's control systems. If the sensor reports out-of-range values, it could indicate a malfunctioning sensor, wiring issue, or a failure within the module itself. There are several possible causes for the DTC P24B8-1C regarding the malfunction of the ELCM pressure sensor. Firstly, the failure of the Evaporative Emission Leak Check Module itself can lead to abnormal readings, which the PCM will detect and log as a fault. Another likely cause is an open circuit in the related wiring, specifically concerning the power supply line VCC6 or signal wire ELCMPA. If any of the wiring components, including the ground wire SG6, are compromised or broken, the sensor will not function correctly. Lastly, a malfunction or failure within the PCM might also cause the DTC to be triggered, indicating that the module in charge of interpreting the sensor's data might itself be defective. When the DTC P24B8-1C is triggered, several symptoms may manifest in the vehicle to alert the driver of an issue. The most immediate symptom is the illumination of the malfunction indicator light, MIL, on the dashboard, commonly known as the check engine light. Additionally, a failed EVAP system can result from this DTC, potentially leading to increased emissions and failing emissions tests. Drivers may also experience fuel efficiency problems, as the vehicle might enter a fail-safe mode to prevent further emission issues, which can affect overall performance. In some cases, the engine may behave unpredictably, such as exhibiting rough idling or stalling due to improper feedback from the ELCM pressure sensor. The first troubleshooting step involves turning the vehicle to the on mode, ensuring the electrical systems are powered and ready for diagnostics. Next, the Honda Diagnostic System, HDS, should be accessed to evaluate the absolute pressure reading from the ELCM pressure sensor. If the value exceeds 856.2 millimeters of mercury, it confirms the failure condition as the fault is duplicated. The identification of this abnormal pressure reading is crucial in diagnosing whether the ELCM pressure sensor is indeed the source of the DTC. It's important to follow these steps meticulously, as accurate measurements can lead to effectively isolating the fault in the evaporative system. In the second troubleshooting step, the technician must disconnect the EVAP leak check module connector, which is an 8-position connector widely used in the system. Once disconnected, the next action is to jump terminals number 7 and number 8 of the connector using a jumper wire. This process forces the ELCM to operate under a specific condition that allows the PCM to measure the pressure sensor data accurately. After this procedure, the vehicle should be turned to the on mode once again, enabling the technician to confirm the readings from the HDS. If the absolute pressure remains below the defined threshold of 856.2 mm Hg, it indicates that the ELCM pressure sensor is likely okay, directing focus towards other potential circuit issues. However, if the value rises above the threshold, it suggests that the ELCM module itself might be malfunctioning. The third step in the troubleshooting process entails inspecting the wiring circuits associated with the ELCM pressure sensor. Initially, the technician must disconnect the PCM connector and jump the system control line, SCS, with the HDS to ensure safe electrical handling. After waiting for more than 1 minute, the technician should verify the wiring connected to VCC6, ELCMPA, and SG6. Each of these components is essential for proper operation. VCC6 delivers the necessary power, while ELCMPA transmits the signal to the PCM, and SG6 serves as a ground. The normal condition for these circuit inspections should indicate a resistance of less than 1 ohm. If any wiring fails to meet these conditions, it indicates an open circuit, which may contribute to the originating DTC. This evaluation is performance-based, meaning if the PCM fails to interpret or respond to input signals accurately, the vehicle's emission systems can be compromised. Replacing or reprogramming the PCM may be required to resolve the issue and restore proper vehicle behavior. Upon completing the repairs, it is essential to verify that the issues have been rectified successfully. To do this, the technician should begin by clearing any stored DTC codes from the vehicle's computer system using the HDS. Once the codes are cleared, a comprehensive test drive should be performed to allow the vehicle systems to reinitialize and monitor for any reoccurring issues. During the test drive, pay attention to how the vehicle operates, especially during conditions that previously triggered the DTC. If the malfunction indicator light, MIL, remains off and no new codes are logged, it indicates that the repairs were successful and the vehicle should operate normally. To minimize future issues related to the DTC P24B8-1C and to promote the longevity of the vehicle's emission systems, regular preventive maintenance is crucial. Technicians should perform detailed inspections of the EVAP system, specifically the ELCM pressure sensor and associated wiring, during routine vehicle checks. Keeping electrical connections clean and free from corrosion is vital, as dirt and corrosion can lead to resistive faults and errors in sensor readings. Regularly checking the condition of hoses, clamps, and connections can also preemptively mitigate potential issues that could lead to DTCs in the future. Moreover, following the manufacturer's recommended maintenance schedule will help ensure that all components of the emission system are functioning correctly. In conclusion, the DTC P24B8-1C signifies an abnormal reading from the Evaporative Emission leak check module pressure sensor, critical for maintaining emissions compliance. Understanding the component functionality, including the ELCM and PCM roles, is crucial in accurately diagnosing and resolving this issue. By methodically following the outlined troubleshooting steps, which encompass inspection of the ELCM, wiring, and ultimately the PCM, technicians can effectively pinpoint the fault. Implementing these maintenance and inspection routines can drastically reduce the risk of future DTC occurrences. ultimately leading to a more reliable vehicle. With proper care, drivers can ensure their Honda CR-V remains responsive, fuel-efficient, and environmentally friendly. Please like and subscribe to the channel. See you next time.